Hello, in this video we're going to be looking at the difference between data and information, which are two terms which seem quite similar, but there is a subtle difference we need to know, and it's going to be important for our future topics as well. So first of all, let's talk about data, because data is not an easy term to just define on the top of your head. So we are looking at data because modern IT systems collect and store often massive amounts of data. So think how much personal data could be potentially stored about you from a company, say. Quite a scary amount potentially. And we'll look at how big data in particular later in the LO can cause an issue, but also can be a good thing for modern IT companies. So we've got loads of data, but what is data? So data is facts and figures presented without context. So facts and figures, usually numbers, can be letters, can be any real type of data. There are quite a few data types we'll look at, but we have no context. So we'll delve into this a little bit more. But for example, this lot of nonsense here you would call data because it's facts and figures. I mean, not a figure and it's not a number particularly, it's a jumble mix of letters and characters, but there is no context to this data. I have no idea what this is. Is it a language? Is it trying to tell me something? Is it something to do with maths? Who knows what it is? So we've got no context, we've got no background surrounding what on earth this is. So without context, how do we know? That's the whole point. So data on its own doesn't tell us anything about what the data is going to be used for, any context like that. And so on its own, data has no meaning. So this data here has got no meaning in of itself. We need some other context applied. By the way, data as a word is a plural. So data is representing more than one unit. A singular version of data is datum, as in D-A-T-U-M, but in normal English usually data is used both singular and also plural, so that's probably what I'll be saying. Anyway, let's look at what happens when we do apply context. So when we are processing data, we start to get information from it. So information is data which is processed. So data processed to have some meaning attached. And by processing, what we mean is really any operation which is applied to the data. So an operation could be something like addition or subtraction. It could be a series of operations like just rearranging it or adding more text next to it, adding an annotation maybe. Any kind of operation you're doing on the data is classed as processing it. And what exactly you're doing will be dependent on your purpose. So we've processed data, we've got some information. So this raw data on the left, this nonsense jumble of characters, I can process it, add some meaning, and actually this data is representing a cat. So what I've done here is just opened this cat picture in Notepad. Notepad can't understand what a picture is meant to look like in text, and so it shows us a random bunch of characters. If I open it in a photo application, it shows me this cat, which makes a lot more sense. So I have some meaning. If I tell my computer that actually it is a photo, it can open it as a photo as opposed to opening it as a text document, which didn't work clearly because this is just a jumble of characters. So we have some meaning, we know it's a photo, we can understand what this data is representing. Okay, so let's formalize this idea a little bit, because we can write out this as an equation, and it's not a perfect equation. If you think too hard about it, it sort of falls apart slightly, so don't. It's just to kind of demonstrate this idea. But information is equal to data, so we've got data originally, but we are adding structure and adding context to make it into information. So I've put brackets or square brackets around the two words structure and context, because that's meant to show we don't always need both. We need one of them. We can't just have information being data. We need some processing. But we might just have structure added, we might just have context added, don't necessarily need both. But in terms of what each one means, so the structure of data is how the data is being organized, how it is being laid out. And I'll show you an example of this in a minute. But context is the surroundings, the circumstances in which the data is being used. So we want to know the background of why we are using this data, what the data means, and the context can help us give this meaning. So meaning is derived from adding the structure and the context, and by meaning I mean we want to know what the purpose of our data is. That's what gives us the meaning, knowing what the purpose of having that data is. A slight complication to this is sometimes the data may be or may have a code within it. The data itself may be a code for something or may have a code embedded in it. So if data has got a code, to understand what the data is, we have to also, to make it information when we're processing it, we've also got to make sure we provide or make clear what the code used is. So by code, I mean, so a code represents something else. So again, I'll show you an example of this, but if I write a secret message, I'm writing a code for my actual message. So I'm not writing my message directly, I'm having some code which corresponds to my true message. So a code, you need to know what the code is to make any sense of what the data is. So we could add a third term to our equation, adding the code as well, so we know what our data is representing. Okay, so let's look at this with an actual example. So say I give you this data here, this alphanumeric data, BA1476. You may be able to guess what this is just from your own knowledge, but it's data if you don't know, right? If you've got no context, you don't know what this is, therefore it is data. And it's not much use to us, really. We want to do some processing to it to make it information. Information is useful, data is not useful if we can't make it into information. So let's make it information. Let's add, first of all, structure. So tell you what the structure of this data is. So let me tell you the first two letters here, BA, represent the operator, and the number afterwards, this 4-digit number, is unique for this journey. So if you didn't know already, you might be able to start to guess what this corresponds to. But say we need more additional information, ironically, if I want to add context. So if I tell you the context, this picture was just me doing a snippet from a departure board at an airport. So now you probably know what this means. You've got context, you've got some background in why this data or how this data has come about. I can also tell you the code. So this data has got a code in it because BA is a code, is shorthand for British Airways. So British Airways being the operator here. So the code is BA. We need to know what BA corresponds to. In this case, it's shorthand for British Airways. So now you've got all three additional bits of information. We now know what this corresponds to. Well, you probably do, but you may not need all three, right? So you may just need one or two to understand what this is. So let me show you. This data came from basically it's a flight number. So here it is over here. It's a flight to Glasgow, which was cancelled, unlucky. But now you've got the additional context, right? You know what this has come from. You may be able to use it in some program or some application. But on its own, not hugely useful if you've got no idea what this corresponds to. Information adds some meaning via context and structure and a code.